P and Q. So what's the biggest messages that we can deal with? What's the biggest message that we can actually deal with this choice?
This is not a number.
Yeah. Bigger than that? Bigger than that? 55. Okay, so any message that gives us a number less than 55, we'll be able to handle with this choice of primes, P and Q. Now, I just chose that, so let's just say that's what we had to do was make sure we have a number that's 55 or bigger. Now, I just chose 3 and 5 because it sort of fits in what we're doing, what we want to do here. But now, what I want the person to appreciate is that's just an arbitrary choice of prime numbers. Any prime numbers that you, well, 2 prime numbers that you wanted, so long as they're count bigger than 55, would satisfy. Okay, so the selection of the P and Q is not imperative at all. There's an infinite collection there, and it just has to be suitably large. Okay, so we've chosen 3 and 5. So what's the first thing you've got to calculate now? N. Okay, that's not an overwhelming difficulty. N equals 5 times 11 equals 55. Okay, we've got N. Next thing we have to calculate is the Euler number, phi of N. Okay, tell me about phi of N. Phi of an N here is 55. What's phi of 55? So you've got to find all the total number of numbers which are relatively prime to 55. Okay? And if you did that in a by hand fashion, it could take a lot of work, but some of you have already yelled out the right number to me. It's the formula. And so how did you get that number 40? You did what? You chose 5 minus 1, multiply that by 11 is minus 1, and you got 40. Okay, so 4 times 10 is 40. So we've got 5, so we've got our phi number. What's the next thing we need to do is, okay, we got to choose our value of E, and it has to be relatively prime to 40. Now, we can choose any one that we want. How many candidates are there? We just have to make sure that it's, any number that you choose here is going to be relatively prime to 40. Well, let's give me some candidates. What are candidates? Is 2 a candidate? 2? No, it's not relative. It's not 2, and 40 has the factor of 2 in it, so 2 is no good. 3 is prime. 40 doesn't have 3 in its factorization, so 3 is a candidate. So 4 is no good. What about 5?
No.
5 any good?
No.
If 5 is prime, is it relatively prime to 40?
Yeah.
No? Okay. 6? No good. 7? A winner. Okay, so this is what I'm saying. You go through and you got a lot of candidates there, but not everyone, but you got a lot of candidates, and clearly the bigger that number, the more the candidates are. Okay, so let's just choose our value for E so that it's nice, easy to calculate. So let's maybe start off with our value of E, the one that I'm particularly fond of, is say the number 3. So we'll use our selection of E in this choice. It's just 3, and let me just say that once again, that's just, we've got a lot to choose from, and we just got to make sure that it has that relatively prime property, and so long as it has that, any one of those is as good as any other one. Okay, so we chose 3. Now what have we got to do? Now we've got to do some work. So we've got to solve this equation. What's the equation that we have to solve now? When we fill in the things, we've got to solve one equation. Anybody give me the equation? 3 times G equals 1 mod the 5n is 40. Okay, so all you have to do is find that value of D such that you have solved, you have a solution to this equation. Now, once again, the whole reason why this works is that you just can't solve this equation analytically. You have to hunt and peck for it. Okay, well, let's hunt and peck systematically and see how fast we can find it. So what's the first one?